This is for Math 7. Chapter 2, Section 6, Adding and Subtracting. With unlike denominators. So the objective here, or the goal, is to change unlike fractions to like fractions. By way of the LCD. The least common denominator. So let's just do a quick reminder of what the LCD, least common denominator, which is also known as the least common multiple to some of us. Let's say that we have two fractions. One denominator is 18 and the other is 12. So we can't add and subtract these fractions based on the fact that they're unlike fractions. So if you use the prime factorization method that I've been trying to review with you over the time, I would prime factorize my 18. 3 times 3 is 9, times 2 is 18. 3 times 2 is 6, and times 2 is 12. Now what we want to do is first determine what the greatest common factor is of these two numbers. Well, they both share a common factor of 3, so I put that there. They also share a common factor of 2, so I put that there. So my greatest common factor is 3 times 2, or 6. Now, the least common denominator part involves using the GCF, 6, and the other two prime factors which we did not use, 3 and 2. So 6 times 3 is 18, and 18 times 2 is 36. So the least common denominator is 36. So what we would do is we take this fraction. I left the numerator blank on purpose. So what factor do we multiply with 18 to get 36? Well, that would be 2. But if we're going to multiply the denominator 2 times, that means we need to multiply the numerator 2 times. Now we're going to do the same thing with y over 12, except 12 is going to have a different factor. What would you multiply with 12 to get 36? That would be 3. Again, if we increase or we multiply the denominator by 3, we're going to multiply the numerator by 3. In short, both denominators are now 36. Once we do that, we can add or subtract our numerators. So now we're going to get into that. So we're going to have unlike fractions. We want like denominators. There it is. So we'll start off with 4 over 5 plus 1 over 6. Now I chose this on purpose. 5 is prime, 6 is composite, but they're also consecutive numbers. Hopefully you've paid attention to some of our definitions, because we've talked about consecutive. If we take 5 and we factor it, it's just 5. If we take our 6 and we factor it, it's 3 times 2. The greatest common factor, well, if you can't circle anything, it's just 1. So the nice thing about this example is the least common denominator is going to be 5 times 6, and that's 30. So over here we're going to take 4/5, and we're going to multiply it with 5 times 6 gives us 30. So it's going to be 6 over 6 plus 1 over 6, and over here we know that 6 times 5 gives you 30, so we're going to multiply this by 5. We're going to also multiply this by 5. So 4 times 6 is 24, and 5 times 6 is 30. 1 times 5 is 5, and 6 times 5 is 30. Now that we have this, we can add our numerators over our common denominator, and the answer is 29 over 30. This was a simple example. We will get into some better ones. These notes are going to be fairly identical to what you had in class. The next one is going to be 2 and 1/6 minus 2 and 2/9. So I'm going to approach this probably the most traditional way possible. First of all, let's determine our LCD. So 6 is 3 times 2, and 9 is 3 times 3. Our greatest common factor, and unfortunately there's only one common factor, is 3. I said unfortunately because I really prefer having multiple numbers circled. It makes doing the LCD a little bit easier. So again, we're going to take this number, our GCF, which is 3, and we're going to multiply it with whatever factors were never circled. So our LCD is 3 times 2 is 6, and 6 times 3 is 18. Now, when we work with mixed numbers, you have to remember multiple things, but we're going to approach this example very straightforward. First, we're going to change both mixed to improper. So 6 times 2 plus 1 is 3 over 6. And then 9 times 2 plus 2 is 20 over 9. Now we're going to work with the LCD. So what factor do you multiply with 6? Here's your 6. To get 18. That would be 3. You'll notice I'm showing this one ever so slightly different from the last one. I'm just showing you the flexibility of the problem. I don't have to put this factor on the inside or the outside. It's commutative. So 9 times what gives me 18? Well, here's 3, and here's 3, so that's 9. That leaves me with 2. So now I multiply across. 3 times 13 is 39. 3 times 6 is 18. 2 times 20 is 40. And 9 times 2 is 18. (39 minus 40 over 18 is negative 1/18). There you go. This next one's going to have 3 terms in it. Sort of important to go over problems like this. 1 over 2 plus 4/12 minus 3/4. I haven't talked about really identifying your denominators yet, but clearly that's what this section is all about. Here's a 2, a 12, and a 4. None of them are alike, so here we go with 2, 4, and 12. 2 is prime, so that's the factor. 4 is 2 times 2, and 12 is 2 times 2 times 3. Now this one's ever so slightly different. The greatest common factor is the one factor that can be found in all three lists. So the GCF is 2. Now when it's time to do the LCD, we have to do something ever just slightly different from all the others. This 2 and this 2 are common in 2 of the lists because, well, 2 only has one 2 in it. So actually, this is a common factor of these two numbers. So here's our GCF, 2. And then this is a common factor of these two numbers, so we put it here. And then this is the only one that's left over all by itself. So 2 times 2 is 4, times 3 is 12. So the LCD is 12. So our job is to now change each one of these to 12. If they need changing. This one doesn't. So 2 times 6 will give us our 12. So this is going to be 6 over 6 plus 4 over 12 plus 3/4 times, well, here's your 4 right here. 4 times 3. 6 times 1 is 6 over 12 plus 4 over 12. Excuse me, this was supposed to be a minus. Minus 9 over 12. Now once all of these are the same, we can add and subtract all our numerators. So 6 plus 4 minus 9 all over 12. 6 plus 4 is 10. 10 minus 9 is 1. And there it is. So remember to just play this video as slowly or quickly as you like, pause it when you need to, and review it or replay it when you need to. Good luck, everybody.